So you go to the county fair or something like that, and there's a Ferris wheel. The diameter is 600. As soon as I see diameter, I automatically cut it in half. That means that the radius is 300 feet. Because all the formulas that I use, they've got radius, not diameter. So go ahead and cut diameter in half, radius equals 300. It takes 12 minutes for one rotation. Find the angular velocity. So the angular velocity means if this thing is going around in a circle and there's some happy customer right here riding the Ferris wheel, and then you go to the point where it rotates in the center of the circle. And if you were standing on that point or somehow clinging to the side of it, and you have to rotate around and watch this person go around, then as you're right there in the middle, how fast do you have to rotate? That's what angular velocity means. In the next podcast, number 27, we'll do the linear velocity. And linear velocity means how fast is this person actually going around the outside of the circle? You might be thinking, why is it called linear velocity if they're going in a circle? Well, imagine your car or truck or bus or whatever vehicle you get around in. Its wheels are round, and yet you can go in a straight line. So the same thing, you can take this information, which is going around in a circle, you could cut the circle, lay it out in a straight line, and however fast they're going around, that's how fast they would be going if they went in a straight line. Okay, but anyway, back to this, the angular velocity. Well, basically, we just need to know what's the time and what's the angle for one rotation. So for one rotation, that would be 360 degrees, or if you're using radian, that would be 2 pi. In this problem, I did not say which you're supposed to use, degrees or radians, so for extra fun, I'm going to do each one. So angular velocity, omega, which looks like a curly W, that one just looks like a W to me. But anyway, it's just the theta over the time. That's it. So this would be 360 degrees every 12 minutes. And 360. Oh, look at those squiggly lines on there. I need my deck of cards. 360 divided by 12 is 30. So this equals 30 degrees per minute. And that is one perfectly acceptable answer. I could also use radians. Or I could give this answer, the omega equals 2 pi divided by 12. And then when you reduce that, it's going to be pi over 6. And then this would be in radians per minute. By the way, radians is sometimes just abbreviated R for radians. And pi over 6 is equal to 30 degrees, so that seems like it's just right.